All right, hi everybody. Welcome. Thank you for coming. It's so nice to see so many faces here. Some new, some I recognize from last year. So today we're going to be talking about Workbrew and how to say yes to Homebrew. So in this session, I'll be talking a bit about some of the challenges of Homebrew and kind of ways that you can mitigate them, and we'll also go into kind of an overview of how you can use Workbrew. We'll do a live demo. Just to start, I have this QR code up on the screen. This will give you a PDF of a bunch of stuff to use with Homebrew, but also this will give me your contact details. So if you want me to be in touch with you, fill this in. I will send a follow-up after the event. You'll get my contact info that way. You get a copy of the slides. You get a summary of all the stuff that goes on at the event. So I would really appreciate that if you do that. But yeah, so to get started, this is how to say yes to Homebrew. My name is John Britton. I'm the co-founder and CEO of Workbrew. My background, I'm a software engineer by training. I went to school in upstate New York at RPI, studied computer science there. I got my start in the tech industry at a company called Twilio, where I was a developer advocate. I worked at GitHub for a number of years, leading their developer go-to-market. And I started Workbrew a couple years ago on the basis of my passion for developer tooling. I love developer tools. I've worked on developer tools my entire career. I'm also a contributor to Homebrew and a very heavy user. My entire machine is fully automated with Homebrew. I have my dot files up on the internet. You can go and see them and set up your machine the same way if you'd like. And I've had this idea for a long time around improving the use case for Homebrew. And when I set out to try to find the best problem to solve in this space, I started talking to what I had never heard of before, Mac admins. I'm new to this community. I've been here for about 2 years interacting with this group. And as I started to talk to people, it became very clear that there are a lot of problems with Homebrew that cause you headaches every day. And so we made it our mission to solve those problems. So here's our agenda for today. We're going to start with a brief overview of Homebrew, talking about what it is, how it works, why it's important to the developer ecosystem. Then we'll talk about a few reasons why we say no. So what are the things that cause us heartburn? What scares us about Homebrew? We'll then go into some things about how we can help. I'm really excited about this section on advanced Workbrew. We're going to go into some really detailed features. Then I'll show you a live demo. Following the demo, I'll give you a quick 1 or 2 steps on how to get started. We'll have a Q&A, and then we'll end with a little bit of what we're doing at the Mac Admins conference on the rest of the next few days. So Homebrew. What is Homebrew? Homebrew is the #1 app store for developers. If you think about it, if you really, really need to distill it down, it's a place you can go to get all the tools you need to do your job. It's massively popular among developers. Some important notes about Homebrew. It's open source. So it's been around for about 15, 16 years. There are thousands of contributors. And it's essentially become the industry standard on Mac OS. So most of us may be familiar with using other operating systems like Linux. They come with a baked-in package manager for the operating system. Mac OS does not. So in our case, Homebrew has kind of filled that void. It looks something like this. Brew install Python. You just open up your terminal, you go on the command line, type in brew install and whatever you want, and you're up and running in a matter of minutes. Homebrew includes pretty much everything under the sun. If it's installable, you can probably get it through Homebrew. The things that you can't get through Homebrew are things that are not notable. And in those cases, you can even package them yourselves and use your own kind of distribution mechanisms to install them with Homebrew anyways. So you can find open source programming languages, IDEs, libraries, all your dependencies. You can also get closed source software like desktop applications. You can install Google Chrome, Zoom, Slack, all the common utilities that people use. And you can also do internal software. So if you need to make your own kind of custom CLIs for your teams, you can package those up and make it really, really easy to self-service install. That's annoying. To self-service install kind of any software that you need. So Homebrew is everywhere. It's trusted by tens of millions of developers every day. It's estimated there are about 35 million devices with Homebrew installed. It's effectively the default package manager for Mac OS, but it's also multi-platform. You can run it on Linux. So there's a project called Linux Brew, and it also runs on WSL, Windows Subsystem for Linux. So you can really use it everywhere that you're doing your development. But there are a few problems with Homebrew. Homebrew was designed as a single-player tool. The idea is that a developer has their machine, they go out, they install Homebrew, they configure it how they want, they install all the packages they need, and they're all fine off to the races, but they're kind of in isolation. And that's not the world that we live in. You know, we work in teams, we work in organizations, and we have requirements around those teams and how they work. And so we really need a way to do this in a multiplayer fashion, a way that we can say, how does this team collaboratively work on this kind of stuff? Another challenge is the lack of visibility. So in a world, I imagine all of you have some fleets of Macs that you manage. Many of your users are installing Homebrew and installing packages, and I've heard over and over again that this gives people heartburn. They don't know what's going on because they have no idea. They have no idea what's installed, what versions are installed, how it's being used. And then lastly, there are no guardrails. So many of us work in organizations that are regulated or have some kind of high security bar that we need to keep, and Homebrew is kind of like the Wild West. I like to think about it as like two ends of a spectrum. We have like device management. So I'm sure all of you are using device management. Effectively, what device management does is it locks down the device. It prevents you from doing things that you want to do or things that you shouldn't be doing. And Homebrew is the opposite. You install Homebrew, and it's just like a giant open door that lets you do whatever you want. And there has to be kind of a happy middle ground in between those two places. And so that's what we're here to try to solve. So when you're using Homebrew, before Workbrew existed, and many of you who don't use Workbrew today, what can you do to solve these problems? Well, the first strategy and the most common strategy that companies take is to do nothing. We just say, we don't use Homebrew, it's not allowed, but nobody really checks, it's all fine. This is like 90% of people do this. Some of the folks are a little bit more rigorous, and they use a system that I call informed trust. And the idea behind this is that you have some kind of best practices, and you train your team, you write documentation. When you join, there's a README that says what to install. If something's not on that list, you don't install it. Trust but verify, right? It's mostly trust but blindly trust them. And then lastly, you can roll your own solution. And there are a number of companies, many that I've spoken to in the top 100 companies that do this. It's unacceptable to be in a world where they have no visibility into what Homebrew's doing, they have no control, there's no guardrails, and so what they have to do is they essentially re-implement Homebrew for their giant organization. This is very costly. You need an entire team. Every time a new macOS release comes out, that's one more thing that you need to make sure works with the next release. So it can be really challenging. But we've learned a lot from the folks who've done this, and we've taken their lessons and rolled them into our product as well. So let's talk about some of the reasons why we say no to Homebrew. Does anybody actually prohibit Homebrew in their organization right now? No. Okay, cool. It's surprising. I'd say I run into every week a few companies that say, yeah, we just don't use Homebrew at all. And it's a major blocker. It causes developers to lose productivity. Kind of the main kind of conversation that we're having with the IT teams is they come in, they say, look, we need to get our hands around this thing. We need to know what's going on, but we can't kill the productivity of our engineers. And so let's talk about some of these reasons. So developers don't usually say no to Homebrew. At least I haven't heard them. They're all saying they want Homebrew, they want to use it all the time. So they're not on this slide. But the three main kind of categories of people that I talk to about the difficulty of using Homebrew in the organization is IT, security, and risk and compliance. Within the IT department, there's a massive administrative burden for managing Homebrew. Not only do you need to figure out a way to install it for your end users, you need to keep it up to date, but you also need to know, how do I get the packages that we need onto those devices? How do I see what's installed? I know many companies where they've done things like they use Jamf, and they've written a Jamf policy that essentially adds a Jamf self-service item for each important package that the developers use. So what they have to do is every time a new version of those packages comes out, they go to Jamf self-service, they update it, and then their developers have the amazing experience of, I want to install OpenSSL or Python or something. They have to open up Jamf, go to Jamf self-service, click a button in Jamf self-service, and get an out-of-date version of the product. One of the reasons why we will kind of want to block or say no to using Homebrew is it's just a huge administrative burden to keep it in line with what we need to do. Another is the lack of integration with third-party tooling. I know a lot of folks use security tooling or just monitoring tooling on their endpoints, and they're really good at looking at things like the applications folder and saying what's installed on this device, what could be updated. but most of them just ignore developer tools altogether. They don't look at CLIs, they don't look at libraries, they don't look at languages, they don't look at what's installed within those languages. And so what you have is a giant blind spot around developer tooling. Another reason is that it's a little bit scary to look at the size of the Homebrew catalog. The official Homebrew catalog, the Homebrew core and Homebrew cask repositories, have close to 15,000 packages in them. And by default, they're all enabled. You have no way to filter them, set any kind of categorization around them or anything like that. And then lastly, this is one that, coming into the IT field over the last couple of years and seeing, the day-to-day roles that people are playing, patching is a really important thing that we need to do. And Homebrew is just completely unable to be patched from a centralized system. There's, you can tell your users, hey, you have an outdated version of Git or OpenSSL or whatever, please run brew upgrade Git. But there's no kind of centralized way to do that. And so this is just another, another burden. If we have this mechanism for people adding software to their machines, now we have to figure out how do we patch it all the time? How do we upgrade it? What do we do about vulnerabilities? On the security front, there's the potential for unverified sources. So this is actually twofold. One unverified source is, where did Homebrew come from? And I'll talk a little bit about that later. The second is, for each of those 15,000 packages, while Homebrew sits above other package managers, in my opinion, in terms of the security of the packages that are distributed in the official repositories, because every package is reviewed by a human, in contrast to some other package managers where anybody can publish whatever they want, whenever they want, there's still no accountability or verification of this package with this name came from this developer, and that developer is the right developer, right? So how do we verify that? From a security front, probably the number one thing I hear from the security folks is, how do we find out about vulnerabilities, and how do we fix vulnerabilities? One that I was not that accustomed to when we first started building Workbrew, but became a very important issue, is the concept of standard users versus admin privileges or pseudo privileges with regards to Homebrew. So just for a little bit of background, when you install Homebrew, you need to have pseudo privileges. In order to install Homebrew, you need pseudo privileges. You need to be an admin. So either all of your developers, when they start their jobs, they get admin privileges, maybe for a set amount of time, or you set it up for them, but an administrator has to install it. Or you might try to cobble some kind of a script together that works with your MDM to try and install Homebrew and go that route with the pseudo privileges. But then once Homebrew is installed, it's really designed to be installed within user space and to be managed by user with pseudo privileges. And so there are a number of tasks that you might be doing as a developer in Brew that require pseudo. And if you don't have it, you're going to be blocked. Examples of this are installing any cask. So a cask is a package in Homebrew that's a binary-based package that comes from an upstream vendor pre-compiled. So something like Google Chrome or Zoom or something like that. Many of those packages come with PKG installers from their vendors, and those PKG installers will be able to do anything on the machine and therefore require pseudo access. So you can put yourself into a state of your end users not having pseudo, being blocked from doing their work, and things like that. And then lastly, in Homebrew, there's no easy way to block packages, to remove packages from the ecosystem. On the risk and compliance front, we work with lots of companies in regulated industries: finance, healthcare, insurance, government, you name it. All of these companies have some kind of either certification that they need to meet, like ISO, SOC 2, HIPAA, PCI, and all of these compliance frameworks have checklists of many, many, many different things that you need to be able to do. And Homebrew is quite difficult to do those things. You don't have a centralized inventory of everything that's installed. You don't have a way to say, when there's a vulnerability, I can patch it within 14 days and audit that and things like that. There's also a lack of auditability and governance. So, within Homebrew, if you want to know what happened on a given day or a given week on these machines, like, tough luck. Unless you have some kind of monitoring tool on the device, checking it every, so on. There's no monitoring. And then lastly, many of these companies that are regulated, they depend on Homebrew and their developers being productive, and they need someone to call when things go wrong. So official support is another thing that's lacking there. So these are all reasons, and there's probably, I could probably fill up 3 more pages of reasons. These are the most common ones that I hear, the biggest ones. So I mentioned before about the source of where you get Homebrew. This is an attack that happened in January of this year. A malicious actor created a fake Homebrew landing page and then went to Google and used the Google Ads product to pay for sponsored links to make it look like the official Homebrew website. So even in the URL, it says brew.sh, which is the official domain. When you click it, it takes you to a malware site. And this version of Homebrew was installed, and I've spoken to customers of ours who've actually been victim to this, and then they had malware and they had a whole incident and they had to go back and handle it. So this is a big problem. Developers, when they go out, they're just trying to get their job done. They're not malicious. They type in brew, they click the button, they move as fast as they can, they copy paste that command, and then they're off to the races. And so this is another reason why IT security professionals are very scared, worried, concerned about how brew is used in their organization, and they might be inclined to say no. So I'm here to talk to you about how we can help with this and why you should say yes to Workbrew, to Homebrew for your users, and give you some tools for this. So what is Workbrew? Workbrew is enterprise-ready Homebrew. It's essentially a management tool built on top of Homebrew. We're Homebrew at the core. We're the same code base. We're not a fork. We're not a modified version. What we do is we contribute to the open source project APIs. Those APIs enable us to do management tasks inside of the Homebrew open source project, and anybody can use those APIs. So on Friday, there's going to be another talk by my colleague, Valentine, who's going to talk about Homebrew, and he'll talk about some of those APIs and how you could build some of this tooling yourself. The TLDR is don't go roll your own, use our product, it's much easier, but if you'd like, those are all in the API. And our kind of thought process here is that developers love Homebrew, and Workbrew can be the security, IT, Mac admin approved way to get it. So here's how it works. What's at the base is Homebrew. On top of Homebrew, we've built a couple of components, an installer, an agent, and a console. So the console is kind of like your web-based management tool, and we'll spend most of our time on that. But I want to spend a little bit of time talking about the installer and the agent and how it all comes together, because we're Mac admins. We know how the Unix underpinnings of Mac OS work. So we ship a PKG file. The first thing about that PKG is it's signed by us. So it's coming from us. It's verified. We have integrations with all the major MDM providers. You load that PKG into your MDM, and you can deploy it with one touch to all the devices in your fleet. What will happen is our PKG installer will install Homebrew in a special location that's isolated from the user where they have no access to it. And then it will install Workbrew on top of it as a wrapper. And if you go to the Homebrew open source project and you look at GitHub, you'll actually see there's some configuration options called Homebrew Wrapper. We added all of this functionality to the open source Homebrew project so that you could build this kind of stuff yourself as well. But this is how it works. So we put that on your machine, and then essentially if you've ever used something like a version manager for a programming language like PyEnv or like NodeEnv or something like that, which is essentially a wrapper around the executable for some kind of tooling for software development, Workbrew works a similar way. We put a binary on the device called brew, and we put it in your path, and when you run brew, what happens is it executes our binary instead of Homebrew. We run all of our checks on the commands, we make sure it's in policy, and then we pass it through to Homebrew if it's applicable, if it's allowed, if it's within the guardrails. Then the other thing that the installer does is it sets up some system groups. So we create a group on the system called the Workbrew users group, and that's how you manage whether or not the end user is able to use the brew commands. So you could install Workbrew on any number of devices, don't add any of the users to the Workbrew users group, and what you have is essentially a software delivery platform where you can go to the console, you can push out any software you want that's available in Brew, all managed centrally, and the end user has no access to Brew. They don't need to know what Brew is. So if you use something like Installamator or Monkey or kind of some self-service tools for installing software, this could be a viable option for you to do that as well with the same underpinnings and developer support of everything else. So once you get that up and running, we put the agent on the device. So the Workbrew agent, what it does is it checks in and sends inventory data of all of the packages that are installed, all the version numbers of what's installed, back up to the console, and it's also responsible for the remote management stuff. So if you want to install things, set default packages, the agent will handle that. So essentially, the functionality of Workbrew falls into 4 categories: deployment, analytics and observability, remote management, and security and compliance. And so I'm going to walk through those now. So on the deployment front, we aim for Workbrew to be the easiest way to install Brew, period. The best, the easiest, and like I mentioned, it's a PKG file. You stick it in your MDM, and you're off to the races. This is in contrast with your developer goes, searches for Homebrew, grabs a command, runs it, maybe runs into some problems. It's very, very simple. It's also integrated with all of the MDMs on the provisioning basis. So if you have a new device from Apple Business Manager, it connects to your MDM. The first time it turns on, Brew is installed. Once Brew is installed, we install all of your default packages. So really, really easy to get up and running. The last thing I'll say about this is I'm sure many of you have endpoints that have Homebrew installed already. And I get the question all the time, what happens if I want to use this with an existing fleet? Well, we've made it so that it's a no-op for the developers. Essentially, it's a non-disruptive upgrade. When you run the installer on the device, we'll detect that Homebrew is there, we'll install the wrapper, we'll set up the permissions as I described, and we'll start reporting that data back to the console. All of the packages that were installed by the developer before stay installed and continue working, and they're able to continue using Brew. And in most cases, it's totally transparent to them. On the analytics and observability front, we really look at inventory and how the tool is being used. So you can get a list of all installed packages, you can get a list of all the versions, and you can get information on things like who ran which commands when. So if you have an incident, you can go and you can investigate that stuff. If you have an audit that's happening and you need a screenshot of some proof of something, you can go in there and you can get that really easily. Or if somebody's having trouble, so a developer is saying, hey, my dependencies aren't working the way I expected, they come to the help desk, you can go in and you can help them as well. On the remote management front, there are really 2 layers to this. At the top layer, and this is relatively new, I don't know how many folks were here last year, but last year I demoed Brew commands, which are a way to run any command you can run with Brew on any subset of devices in your fleet. So an individual device, a group of devices, or every device. We've since been adding more and more high-level abstractions into the product to make it easier for you to manage things at a company-wide level or organization-wide level. And so what you see here is something called default packages. Our default packages feature is built off of Brew files. So in Homebrew, again, we're building on top of the open source tooling. In Homebrew, there's a feature called Homebrew Bundle, which allows you to specify a configuration file and install the software that's specified in the configuration file. What we built with default packages is a way for you to centrally manage those lists of default packages, assign them to individual devices, groups of devices, or the entire fleet. And rather than writing code and using some kind of configuration file, you have a real-time search where you can search through all the packages, pick the ones you want, add them, remove them, and then save this, and it will automatically install these packages onto those devices. What's really nice about this is if you have a new joiner on your team, let's say you have a data science team and they need Python and some kind of Tableau or whatever kind of software, they join on their first day. If their device is in the data science group in your MDM, that information will be synced over to Workbrew automatically. They'll get the default package for data scientists, and all of those software will be installed on their device when they log in the first time. So really, really easy to use. And then lastly is security and compliance. The number one feature that comes up in this area is vulnerability detection and remediation. So what you see here is a list of packages that are installed in a workspace and the corresponding CVEs that we've detected. The way that this works is we have a database of all known CVEs, and we cross-reference that with all the versions of every package in Homebrew, and then if you have any of those vulnerable versions, we'll give you an alert. Those alerts will come through as obviously in the Workbrew console, you'll see it in the web interface, you'll see it as an email, and you could also see it as a Slack message or a webhook. If you have a webhook, you can also automate things with that, which is really cool. This also has some vulnerability scoring, one-click remediation. If you click that upgrade button, it will just get patched automatically. So it's really easy to see the value here. On the other front with this is policies, setting guardrails, which I'll show you in the demo. So now I want to talk a bit about some advanced functionality in Workbrew, starting with access control. So the way that policies work in Workbrew is you go into the console, you set up the policy, you say, these packages are not allowed, these packages are allowed, whatever. And inevitably, this is going to lead to a situation where someone on your team wants to do something that they're not supposed to do. And so what happens? So you can actually set up your own kind of configuration for the error message that your end user will get on the CLI. So this, in my case, it says, contact the security team on Slack in the security channel and we'll get you sorted, right? But you can customize this to however you want. So this is really useful for always making sure there's an escalation path, that developers don't end up blocked. Additionally, the Workbrew console supports role-based access control. So you can say, I'm an admin. We have, some of our team leads are write users. They can adjust policies. And some of them might be like in our compliance team. And we don't want them to break anything, but they need full access to read. So they can go in and do that. And you can also set up kind of, allowed domains. So you can make sure that this is locked to your stuff. I mentioned this briefly before, but this was one of the most requested features in the last year since I was at PSU. Device group syncing. The premise of this is that we want to be able to manage teams, departments, groups, types of hardware, laptops versus desktops, Intel versus not, or whatever. And so rather than having to deal with lists of serial numbers and whatnot, we built this device group syncing feature, which is really handy because it's zero configuration. You install Workbrew, we pull the serial number from the device, you attach a read-only API key for your MDM, and we pull all the information, including all the group information, automatically into Workbrew, and it just shows up, and it just works. So this is really, really powerful for managing who gets access to what. Up next, fleet health. So we talked a little bit about vulnerabilities before. This is an example of a Slack notification that you would get when a vulnerability is found in your workspace. So first thing you see is that, hey, we found a new vulnerability. Then next, it's a notification that says, the vulnerability was detected in your workspace, and how many devices. And if you click that one devices, it will give you the list of devices. Click here to upgrade, we'll patch it. But if you have automatic vulnerability patching enabled, you'll get the next notification, which is, we patched it. Problem solved. You don't have to do anything. You're informed, but there's nothing you have to do here. We've had some situations where new customers will come in, and they'll install Workbrew on 50, 100 devices. They'll go into their dashboard, and the first thing they see is 400 vulnerabilities. And then 30 minutes later, it's 10 vulnerabilities because something wasn't patched because a machine got turned off. And then that machine turns on, and then it gets patched. So it's really, really nice. Up next on fleet health is something called violations. There are two types of violations that we alert on and raise up to the admin so that they can remediate them. The first is called an access mode violation. So I mentioned about this idea of the Workbrew users and giving people access to the brew command or not. So you can specify at an organization, a workspace-wide level, or at a device group level, what you expect the access of that user to be. So there is a little bit of complication because Mac OS supports multiple users. We key on devices. So we do we have all the smarts to figure out the right answer, but it's not directly one-to-one with users. But what happens here is if there's a mismatch between an observed user having access or not having access as expected on the device, we will alert you about it, and then you can fix it. So in this case, what you see is that there's a test user. Its permissions are restricted. So if I was logged in as this user, I would not be able to run the brew command. We expected from their device group that they should be in the sudo mode. They should be able to do whatever they want. And so this will alert. The other kind of violation that we alert you on is policy violations. So a policy violation would be, let's say I blocked OpenVPN. I don't want people to install OpenVPN for whatever reason, and somehow it's installed on a device. That would show up under a policy violation, and you could click a button to remove it. We also have a feature that will automatically uninstall those packages if they're found. And you might ask, how would it be possible to end up with a violation? Well, because you can have devices that have Homebrew installed, and then you upgrade them to Workbrew, when you do that upgrade, they could already have packages that are not allowed installed. We don't automatically uninstall them unless you configure that. You can turn it on, and it will be removed, or we'll give you a violation. My recommendation with this, if you decide to roll out Workbrew, is to start from a visibility-first approach. You roll out the tool, you see what's out there, don't block anything, don't turn anything on, and then work with your user base to say, hey, we want to really standardize on X tool versus Y. Can we start to remove this? And work with them to get it removed. And then once you get to a nice, like, clean, organized state, that's when you start to put in some of the policies to prevent it from getting out of line. Up next is supply chain controls. So things that help you with ensuring brew is coming from where you think it is, and the packages that you're getting are what you think they are. So we have a functionality that we added called allowed taps. So this takes a little bit of explanation. What is a tap? In Homebrew parlance, a tap is a repository of packages. The official Homebrew project has 2 taps, Homebrew Core and Homebrew Cask, that contain those 15,000 packages that everybody thinks of as Homebrew. Homebrew Core is source code based, which means every package in that repository has the source code available. Homebrew gets the source code, and then Homebrew builds the binary and provides you with the binary. Homebrew Cask is binary-based packages. So the upstream vendor produces the binary. Homebrew goes and gets the binary and provides it to you. We don't compile the binary. But beyond those 2 taps, there are lots and lots of public taps out there. You know, Microsoft has taps. Heroku has taps. Like there's thousands of them, where anybody can distribute any arbitrary third-party code by creating a source code-based package or a binary-based package, putting it into their tap, and then sharing that. So what you'll find is that if you have any number of users of Homebrew at your organization and you install Workbrew, you'll get a list of all the taps that are in use. And you'll be surprised, there's 50, 60 different sources that are not part of the Homebrew, official taps that people are using. And legitimately, that could be any arbitrary code. Anybody can make a package, put it into a tap, make it public, and put it out there. So you never know what's in there. And so with this allowed taps feature, what you can do is you can set your organization to only support the official Homebrew Core and Homebrew Cask taps, and then have a mechanism for people on your team to request other taps. What you can see here is we have a 3rd tap. That's an internal tap that we use. This can also be applied on a device group basis. So up until maybe a month ago, it was organization-wide, but now you can have different sets of policies around allowed taps for different device groups as well. So private taps. A private tap is essentially a tap that belongs to your organization. So in terms of distributing software, we're talking about maybe you have some internal CLI tools you want to distribute. You could package those up, put them in a private repository on GitHub, and then let people install them or install them automatically for your users. The problem with this is the way that Brew is built, it speaks directly to each tap. So when I do brew install, tree or something, it talks to the repository that contains the Homebrew Core tap. It pulls down that definition. It pulls down the files. When I want to install something from a private tap, I have to have some mechanism to authenticate to that private tap. So there is a mechanism for this. Let's assume we're using GitHub as our source control. You can go into your user account in GitHub and create something called a personal access token. You can save it in an environment variable on your machine. And now when Brew tries to talk to that private tap, it will be able to access it. Now, if you have 1,000 devices, you only have 2 choices. Instruct each of your 1,000 users to go and create that personal access token and set it correctly on their machine, which is a nightmare. Or create one personal access token and distribute it to all of them, which is also a nightmare. So don't do either of those things. What we built with private taps is you can create one access token, give it to Workbrew. Workbrew will connect to the private tap and redistribute it out to all of your users. So there's no authentication necessary for private taps. And then we have this thing in Homebrew, actually, called attestations. We have some functionality that's in Homebrew and some that's in Workbrew. So to go further to did the package I installed, is that really what I think it is? Maybe six months, a year ago, something like that, Homebrew released a functionality called attestations. And what attestations are is they're a cryptographic signature of the binaries being built by Homebrew. But what's interesting about those signatures is it's not Homebrew signing them. It's actually GitHub Actions signing them. So Homebrew manages the source code, the formula that describes how to build the package. Then that formula goes on to GitHub Actions. It fetches the source code from the upstream provider. It builds the binary, and then GitHub Actions signs the binary. And that binary is distributed out to Homebrew. What's nice about this is you now have a guarantee that the binary that's signed with that signature was built on a specific GitHub Actions instance with a specific formula to build it. So the instructions that were used and the source code that were used are all verified. So that's all in Homebrew. In Homebrew, there's a configuration option that's currently disabled by default. I expect in the future it will be enabled by default, which is called Homebrew Verify Attestations, which means that every time you install a package, we check those signatures from a known source, make sure they're right, validate that those binaries are built the way we think they should be built. Now with Workbrew, if you wanted to do that across all of your devices, you'd have to tell every single one of your users to turn that on, or don't turn it off, right? Like you'd have to make sure they don't turn it off. With Workbrew, what you can do is you can go into the Workbrew console, set a configuration option, and that will automatically go out to all of your devices, and it will be enforced, meaning they can't change it. It will be guaranteed to stay that way. So this is really valuable if you have supply chain concerns. Up next is the Workbrew REST API. So this is all about how you can automate more of your jobs, right? I hear from IT admins all the time, they say, I want to set it and forget it. I want to get this thing in place. I don't want to manage it every single day. I just want it to tell me when something's broken. I'll fix that thing, and everything else I want to be automated. So we've taken a API-driven approach. The entire Workbrew console has an API that matches everything you can do in the console, and I'm going to show you some of those things. So this is a summary of the API. If you go into the console, there's a documentation section. You'll get this list of endpoints and what they do. It's pretty simple to use. It is the V0 of the API, so I expect things to change. We've been getting a lot of customer feedback and improving things. So if you use this and you have feedback, please send them my way. So the first thing is devices. Pretty simple. You can get a list of all the devices. You can see things like what workspace is in. You can see when was it last checked in, when was the last command run, what type of device, OS version, yada yada. Very, very easy to get. That's kind of a start there. Up next is formula. So we have formula and casks, the two types of packages. They're separate because they have different implementations. But you can get a list of all the packages, all the formula that are in your fleet. So this is useful if you need to do things like inventorying or reporting what's happening on these devices to some third-party tool. Like if you have a SIM that you want to send data off to, you can pull this data. Similarly for cask, it's exactly the same thing, but for binary packages. And vulnerabilities. And this is one of the ones that's really useful. So you know that we have vulnerability tracking. What are you going to do when a vulnerability is found? I've worked with some customers that have built automations around things like, if there's a vulnerability, we don't want to just auto-patch it because we don't want to break the developer's environment, so we'll alert them. So we send them an alert. And then if they don't fix it within 7 days, we want to remind them or whatever. And if they don't fix it within 14 days, we want to cut off their VPN access. Or if it's over a certain health score or whatever you want to do. So you can do that with this. And then if you want to take actions, we have this API for brew commands. So anything that you could do with brew, you can now programmatically do. And I've had customers that, for whatever reason, they really want to do something via Jamf self-service. And so what they'll do is they'll build a script, they'll put it in Jamf self-service, it'll call this API, and now they're able to give other people on their team, without direct access to the Workbrew console, the ability to do certain actions in Workbrew. What I'm most excited about from the API end is a new feature that we released just a couple weeks ago, which is configuration as code. So this takes the default packages feature we talked about earlier, where you can set what should be installed on which group as a matter of policy, and it will automatically happen, and turns it into something where you can do that with like a DevOps workflow. So we created two things. One is an API endpoint, which allows you to update a brew file. So you can make a post request to an endpoint that describes a list of default packages with the contents of that file and replace it to say, I want these 10 packages to be installed. And you can specify which group it gets applied to and so on. And then we built a GitHub action, which makes it very, very easy for you to use that API. And this is the GitHub action. And so what happens here is you create a repository and you create a file, and that file is a brew file, and you list out all the packages. And whatever's in that file will get us installed on your devices. And this is really nice because one of the things that people come back to us over and over again about is, this is really cool, this gives us all the control that we need, but actually, I have so many people at my company, I don't want to be the one responsible for everything. I want to be able to delegate this to the right people. So what you can do here is you can say, hey, there's 15 different teams, they have 15 different sets of needs, they have 15 different default packages lists, it's assigned to 15 different device groups in Workbrew, and it's all in one GitHub repository, which has pull requests and code review and approval processes. And so any of those managers or team leads or individual users can make a pull request, click merge. As soon as it's merged, it gets installed. So it's really, really powerful. So now let's go into the demo. So let's go here. So the first thing that I'm going to do is just show you, I'm going to make this bigger too. I'm just going to show you Workbrew on my machine. So I could do something like brew dash version, something really simple. So you can see it looks just like brew, but the first thing that puts out is it's Workbrew. And how does it actually work? So if I say which brew, which will tell me where is this command, it's in opt Workbrew bin brew. And because I'm a member of the Workbrew users group, I have access to this. Under the hood, there's still this instance of brew as well, but your end users don't have direct access to that. So now if I want to do something like brew install htop, just a tool, command line tool, pretty easy to do. If my internet works, it'll install it. And then if I go here and I go to policies, so you can see pwgen is disallowed. So I installed a package. But now if I say brew install pwgen, so I get a message. The installation of pwgen was forbidden by my workspace administrator. Contact us on security with any questions, right? So if I want to block certain packages, I can block those packages. So that's how it works on the command line. From a developer's perspective, it's pretty much transparent. Like there's not much I can show you here that's very interesting, other than like, okay, one thing got blocked. Now if we go to the Workbrew console, I'll make this a little bit bigger. I'll walk you through this. So this is the dashboard. When you install Workbrew, you get a summary of everything that's going on. So you can see no policy violations. There are 8 known vulnerabilities, 2 devices out of date, 1 access mode violation, and you can get kind of at a glance vulnerable packages, uniquely installed packages. The internet seems to be a little bit slow in here. So what I'll show you first is devices. So this is a view that lets you see all of the devices in your organization that have Brew installed, and a quick summary of how many packages are installed, when did it last check in, and if you want, you can drill down on an individual device and get inventory information. So you have all the metadata about the device. You can see what groups I'm in. You can assign me to a group, add more groups. But this is where the real data is every single package that's installed. You can see it's up to date, when it was installed. Was it installed as a dependency, or was it just installed as like a thing that the user wanted to install? And information about the versions. So you can see everything here is up to date, but this package, Atuine, is not up to date, and so I have an upgrade button. This is useful for troubleshooting an individual user's device, doing things like responding to incidents or auditing. But more often than not, what you're going to want to do is look at this from a higher level of the entire workspace. So we have this packages view, which more or less shows all the same information, but from a different perspective. Every package and which devices it impacts. So you can see here, for example, we have the Git package. It's installed on 8 devices. I can drill down and see which of those 8 devices it's installed on. So you can see the devices here. And then I can upgrade it everywhere. I can block it, and I can see what vulnerabilities are known against that package right now. So this is useful for discovering how much, what are the popular packages, what are the not so popular packages, what needs to be upgraded, what's out of, what has CVEs against it. So that's kind of on the visibility front. Another thing on the visibility front is this analytics tab, which gives you a history of every brew command run on every device that's searchable. So you can see which machine, which command, when it was run, all that kind of information. So it gives you a lot of visibility. What I want to show you next is here we go, default packages. So we talked about default packages. This is kind of like the main place where you will assign packages to devices. You could go in here and create a new brew file, and you can either edit the code directly, which is brew files are just text files that have a specific syntax, or you can use our visual editor to search for things. So I could say I want to install like Python. So if I search for it, show me all the Python packages. I can choose the one that I want, like Python 3.9. I could choose casks if I wanted to install, for example, Visual Studio Code. Right? And you could add as many as you want here. And what this will do is it will install these packages on all devices in the workspace, or I can go and I can choose a particular group or an individual device. So this is very flexible. And this is exactly what you can do via the API as well if you want to do like configuration as code. So that's default packages. Under the hood of default packages, the way this works is using our brew commands infrastructure. So the ability to run arbitrary brew commands on these devices. And we give you direct access to this lower level kind of API primitive as well. So you can go in here and create a new brew command, say install Python, like that, right? And then it will go out and it will install Python on whatever devices you select, the group, whatnot. Now, when you do a run like that, when you run a command, what happens, let me see if I have a better one here. Go to third page. What happens is here, for each device that's targeted, a command run is created, which is an instance of the command running on that device at a particular time. And when the device checks in, it will get that command, and then it will execute it, and it will report back all of its logs, which are fully visible in here as well. So you can see all the audit logs of what happened on each device. So this is really powerful. You can really do anything that Brew can do. Install, uninstall, upgrade, add taps, pin versions, you name it. If it's available in Brew, you can do it that way. And then moving on to kind of the security and compliance front, if we look at policies, this is where I kind of showed you before you can set up the message that they see. But down here, you can create different kinds of policies. So the one that we saw before was forbidden formula. I want to block certain packages. So I can go in here, and I can list out what package I might want to block. In my case, I mentioned before OpenVPN. So I want to block OpenVPN. I can say OpenVPN and choose OpenVPN. Great. Pretty simple. But what if I want to block all VPNs? So I could do, for example, search here for VPN, go down to the bottom here, and click select all 14, and we'll add all 14 of those items to the list. I can move them one by one. Obviously, this is a textual fuzzy search, so it's not a categorization system. We're planning to add categories and manage those categories and stuff for you in the future, but right now you can just do a fuzzy search, add the packages. What's nice, all of these policies are also device group based, so if you have different teams with different needs, you can set up different policies on each of them. Also on the policies front, you can do the same for casks. We have this automatic upgrades and uninstalls policies. So this is where, depending on your organization, you might have different needs. These are all off by default. But you can turn on automatically upgrading vulnerabilities. If you find a vulnerability, patch it. It will just take care of it. The same thing is whenever a formula or a cask is out of date and there's a new version, we can automatically upgrade those. And then lastly, we have this automatically uninstall forbidden packages, which I mentioned before. If you're adopting existing Homebrew installations and you want to remove packages from them, you could turn this on. I generally don't recommend turning this on until after the fact, once you've got everything up and running. Yeah. So that's policies. Let's see what else is in here. We also have a policy for licenses. So if you wanted to, say, for example, block GPL software or limit that, you could search for different licenses, add that in. Pretty powerful. That's a great question. So let's save that for the Q&A, and we talk about that. Okay. Great. The next thing that I want to show you is kind of under the hood. Similar to device default packages being built on top of brew commands, policies is built on top of something called brew configurations. So if we go to brew configurations and create a new brew configuration, you'll get this page where you can enter the name of a configuration variable and set its value. Very sophisticated UI, but it's giving you raw access to how this works under the hood. As I mentioned, many of our features are implemented in Homebrew as APIs that anyone can use. The value add is that we give you a central place to manage it, and you can ensure that it's not changed. So if you go to the documentation page of Homebrew and check out their configuration options, there's close to 100 different configuration options that you can manage here. So I'll use one as an example, artifact domain. So I'll use this one called Homebrew artifact domain. And I can set this, and I can say artifacts homebrew.example.com. Now, I'll preface this by saying I don't recommend that you do this unless you're in a regulated industry and it's a requirement to like check a box that you have to do this. But what you can do here is what we're saying is every endpoint that has Homebrew installed, rather than going to the public internet and downloading packages and source code and all that stuff, go to this domain. So now you have a single point of entry into your environment where every single package goes through. Some of our customers that find this feature valuable, what they need to do in like the banking industry is everything that enters their environment must go through an intellectual property scan, a licensing scan, a vulnerability scan, some kind of heuristics, and then it has to have an audit log entry that it was scanned and saved and stored for 5 years, right? At the end of the day, the binary that gets installed on the machine is the same exact binary with the same signatures. So this does not give you anything more than like some compliance checkboxes. But what's nice about this is you can set this at the workspace level. All of the devices will have this set, and it can't be overridden. So now if you want to set up some kind of VPN situation, everything happens in-house. It's totally possible. So that's brew configurations. The last thing on the policies and security front is taps, which we had talked about before. So this is a list of all the taps, so you can see what's in use by everyone. And under, we saw under the policies, you can set this as well. So what I'm going to do next is pop back over to my slides. If I remember where they are, here they are. So hopefully you've come to this point and you said, we do want to say yes to Brew. The way to do that is to use Workbrew. And so I want to give you some information on how you can get started. Workbrew is legitimately the easiest way to install Brew for your organization. It takes the burden off your engineers. It takes the burden off of everybody else. It makes it automated, one central way. You're guaranteed to get it from the right place. And it's available with any MDM. So you can do it this way. We have in the back, on your way out, there's piles of guides. There's a different guide for each MDM that has screenshots of what each MDM stuff looks like and how to do it. You could be up and running in less than an hour. This will give you Brew on the devices. And what I want to get at is you can actually do this entirely for free. So Workbrew has a free plan for unlimited users and unlimited devices that gives you access to the deployment, installing a set of default packages for every machine, and visibility into every installed package and every version. So there really is no excuse for not using that, in my opinion. All of the stuff that's in the paid plans, I'll talk about that later. We saw some of that already, but the free plan is an outstanding option for you. So zero-touch deployment, automatic installation of default packages, full visibility, and you get Slack notifications and email notifications free for everyone. We do have two paid plans. We have Workbrew Pro and Workbrew Enterprise. What you get with these are all the remote management and security compliance features. So for the most part, anything that's a write operation is part of the paid plan, barring default packages. In the free plan, you get one set of default packages for every machine. So you don't get to do the device groups or anything like that. But on the paid plans, you can create device groups, have default packages for each one. You get alerts for vulnerabilities. You get OAuth single sign-on or SCIM and stuff if you're on Enterprise. You can block packages. You can do brew commands, policies, everything that's on here. On the Enterprise front, the things that you get are more advanced SSO. You can do automations, so automatic upgrades, automatic vulnerability patching, role-based access controls, so if you want to have different levels of access for different people. Our API also supports webhooks, which is part of the Enterprise plan, and data export, and if you have multiple private taps. So I showed you the private taps thing. If you just have one for everything, that's fine. If you have many to manage, that's an Enterprise feature. So now, you had a question, right? Let's do Q&A. I think I'm supposed to give you this. I hope I don't damage your machine. Oh my.
It's his. Shoot, I forgot. It was whitelisting the licenses. Can you?
Yeah.
So I saw you had. You could forbid different ones, but can you reverse that and explicitly allow certain ones?
Yeah. So this is by far the number one question I get all the time is, can we have an allow list? Why doesn't it work the way I think it should? So the first thing that I'll say is having an allow list is very challenging because you need to either implicitly accept every dependency or explicitly review every dependency. And dependencies change with time. So we don't have an allow list that says allow list, let me allow these things. But we do have a way to get to that outcome, which is I want to control exactly what gets installed on these machines. And so I mentioned about the different access modes. So you can put somebody in a restricted mode or in standard mode. If you want to have an allow list, you're effectively saying you can only have these things, right? So why don't you just install the things that they're allowed to have and call it a day? So what you do is you put them in restricted mode, and then you set up a default packages list, and that's your allow list. It installs all of those things. And then if you want, you can expose them that GitHub action to contribute to it or have an approval process. And what that means, though, is the allow list is effectively, if you want to add it to the allow list, it must be installed. It's not optionally installed, it must. So it's a little bit of a thing there, but our engineering team is working on that right now and making it so that when you put something in the list, it doesn't have to be installed by default. The other thing that I'll talk about with allowing packages versus not is that what I've heard from Mac admins is they're most concerned with casks. So those binary packages, the applications. And so out of the box, the way that Workbrew works is in standard mode, casks are allow list based. You cannot just install any cask that you want. So it's kind of a split down the middle where with Formula, when you come on standard mode, you can install all the developer dependencies you need. But if you want to install a cask, because they often need sudo to install, that has to go through the console, and so that has to go through a default packages. And we plan to add in the future a little bit more around self-service for the users to be able to do that. Answer your question? Mm-hmm. Cool. More questions? There's one over here if you don't mind passing the box.
Somebody throw it.
We're going.
Okay. So what keeps somebody from just bypassing Workbrew and using Brew directly besides just changing the path?
Great question. So the first thing is what level of bypass protection are you trying to get? So we have those different access modes. So if the user is a standard user on the device, what keeps them from bypassing it is Unix level permissions in macOS. They cannot change what's in Homebrew. They can't modify Homebrew. So they can only access, they have no direct access to Homebrew whatsoever. If they have sudo privileges, I mean, frankly, there's nothing preventing them from going around it, right? What does prevent them from going around it is that they're not supposed to, and we have auditing. So if they go around it, it will show up in the console as a policy violation. They did something they're not supposed to do. We'll report on it, all that kind of stuff. And our customers have very different types of security postures. We have some that are like, every developer gets full admin access on the device. They do whatever they want. We just want visibility. We have others that say, we're regulated by 15 different agencies. Nobody can do anything. We have to do it all for them. They must be super restricted. And so we leave it up to the customer to decide how they want to manage that. And then I think the other thing about bypassing is, that's what I was going to say, multiple installations of Homebrew. So this comes up frequently where people will say, well, what if I just install Homebrew on my home folder, right? And I use that. So the way that we built the policies and all of that stuff into Homebrew is that all those configuration options control the behavior of Homebrew. When you have Workbrew installed, we control what those are set to, and there's no way to override those settings. So there are basically 4 places the configuration can be set. The first is at the system level. There's a configuration file for the whole machine. Then at the user level, there's a configuration file for the user. In the project level, there's a configuration file for the current directory. And then the environment variables are the last kind of configuration, and they cascade. So the environment variables override everything. Except in Workbrew, the system configuration overrides everything. And what's interesting about this is if you have one installation of Homebrew in the standard location, it will follow those settings, and you can't change them. But if you have 5 installations of Homebrew in 5 different locations, they will all also follow those settings. So that's what prevents them from going around. Thanks. We have another question over here.
Hello. So I want to ask about the auto-generated groups. What criteria does the agent provide so that those groups are made? And also, can we, I'm pretty sure we can have our own criteria, but say if I have a dev group on one project and another and I need to distinguish between the two, how can I go about that?
Great question. So the way that groups work, so you can create device groups manually. You can go create a group, add devices to it, obviously. Then we have device group syncing. So we will pull in group information from your MDM tool. This is not what I think you were asking about, which is like smart groups, right, where I can set parameters and have groups created. We don't currently have a smart groups feature. Some of the MDMs have smart groups features, and we potentially can sync from those smart groups. But right now it's manually you can make device groups, or you can sync manually or static groups from your MDM, not dynamic groups. I'll take that as a feature request too.
Follow up on that. Can you sync from multiple MDMs for device groups?
So in one workspace, you can have exactly one MDM. However, we support multiple workspaces. So we do have customers that are very large companies that have, divisions by country. And each country has their own instance of Jamf, and they have their own manager. So the way we get around that is we give them multiple workspaces. Each workspace is tied to one, and the administrators of each workspace are, individual. But you can have a shared account over all of them as well. But you cannot sync multiple MDMs in one workspace.
Okay.
Over here we got one, and over there. Maybe this one first. We'll come next over here.
The question is, maybe I missed some part of it. How many applications, or what is the app store size you have? How many applications do you have?
Yeah, so the official Homebrew package repositories are about 15,000 packages. And they're managed by the open source community with a few thousand contributors, and generally they're kept up to date very, very quickly. Can you pass that down this way?
All right.
We can hand it over, yeah. Nobody wants to throw it, huh? Thank you.
Okay. I'm curious, so I've used Brew as a actual user.
Yep.
But I haven't ever managed it myself. I have used Monkey before. Can you describe the differences there? Do you know, does Brew allow post and pre-install scripts, like that type of stuff? And
Yep.
yeah.
That's I think that we can help you get to some of the same outcomes as you can get with Monkey, but we're very different. So I would say the main differentiator for Brew is that it's developer-oriented first, right? So the expectation of the developer is they open up their command line and they use this tool. What we see with Workbrew is that, wow, this tool that the creative professionals, the developers are using and they really love is incredibly powerful, and we can bring it to everyone, right? Why go and reinvent all the plumbing of how to install this stuff when there's a really, really effective tool, Brew, that already does it? So we're trying to build kind of from that core outward to make it more easily accessible. To your question about pre-install and post-install scripts, we don't have anything of the sort. It's just you can install the default package, like the package that comes from Brew, how it is. However, with private taps, you can make your own packages, and packages can have dependencies on other packages. So we've seen cases where, for example, the developer environment at a bank that we've worked with requires some configuration around SSL certificates because they have, I don't know what you call it, but the traffic inspection where you have like your own local certificate, it decrypts and then it re-encrypts. And so one of the packages in Homebrew has its own certificates baked in. And obviously that will cause that tool to not work together. So what they did is they made their own package with their certificates and used the other existing package's dependency. So there's some tooling around that you could do kind of like a pre-install script type of thing. But what I would like to see in the future is more around like application level configs. So when you install, I don't know, let's say Slack, like the preferences for how Slack works are set a certain way, and within my organization or within my device group, they can be set. We don't do that today. Okay, oh yeah. Go back there next.
Hello. Okay, so my question is more around a very niche use case, but application upgrading.
Okay.
So let me share with you the use case, and then you can speak to Workgroup or Workbrew, excuse me. I was at an organization that basically wanted to keep everything current -1 for a period of 30 days. So is there granular control over like what version we're going to upgrade to so that we can meet the requirements to see what breaks before we go current?
Perfect. So Homebrew as a package manager is what's called a rolling release package manager. This is in contrast to if you look at like Ubuntu or something, where they have a long-term support and you have a set of packages and a set of versions and they only do security bumps, right? If you want to get all the new versions, you go to the next distribution. This is very different. Today in Homebrew, there's no support for installing old versions of anything. You can only install the latest version. That said, there's a feature in Homebrew called version pinning, where if you have a version, you can lock it. You can pin it to where it was and not upgrade it. But that doesn't solve the case of, say we pin to 1.0. 1.1 comes out, a new person joins, they cannot get 1.0. They have to go to 1.1 because it's not available. So this is a problem in the Homebrew ecosystem already. We have some tooling that lets us do kind of what you're asking for. It's currently in beta. So if you're an existing customer or user, we can give you more information about it. But I expect it will solve this problem in the future. Right here was next, and then the one in the back will do.
Can you explain how this would work with Artifactory or compare contrast?
So kind of what I showed with the having one single point of entry, you could have an Artifactory mirror of the Homebrew resources and point Workbrew to that. So that's how they would work together. We don't have like a super tight integration. It's literally just if you provide a mirror, we can pull from that mirror. So thanks. In the back in the purple.
We would need to use smart group scoping and scheduling for a lot of controls over some of these apps.
Mhm.
Would we be able to just use the brew commands in, say, policy in Kanji or Jamf to schedule and push that out to specific groups of machines that change over time? Or do we need to keep everything within Workbrew?
So I would strongly recommend against trying to send commands from your MDM to Brew directly. When you do that with Homebrew, without Workbrew involved, when you do that with Homebrew, your MDM is running as root, or it's running as a privileged user. The way that we manage the privileges, it's much less likely to cause problems. There's like a lot of like edge cases around it. With regard to scheduling, Brew commands do support scheduling. So can you tell me what you're asking about, what kind of scheduling you want to do? Is it like recurring schedules or like run at a specific date and time?
It'd be running at specific date and time.
Yeah, so Brew commands support that. You can go in and you can say, I want to run this command once. You set the date and time you want it to run. And it will not, we can't ensure it runs exactly at that time. It's essentially, it will not run before this time. You know what I mean? Once that time passes, a check-in will happen, and then it will run on check-in. The check-ins happen about every 15 minutes. And then it also supports recurring. So you can say, I want to run this command daily, weekly, monthly as well. Are there any other questions out here? There's been some really great ones. Thank you so much. Just before we go, I want to give you just a quick overview of some things we've got going on throughout the rest of the conference. Down in the sponsors hall, we have a table. You can come by and see me anytime. My colleague, Brandon Valentine, who is an engineer, technical account manager at Workbrew, he's giving a talk on Friday at 9 a.m. It's called Homebrew, Balancing the Needs of IT Security and Engineering Teams at Scale. This was obviously all about Workbrew, our product. His talk will be primarily focused on Homebrew and ways that you can use some of those APIs to take advantage of this stuff yourself. So I highly recommend you check that out. Now at lunchtime in the sponsors hall, we got the Penn State Creamery to bring ice cream, so we'll be serving up some ice cream. I'd love for you to stop by and grab some. And then we're also running a raffle, $500 Apple gift card. So to sign up for that, you just stop by our booth and fill in the form. So thank you all very much for coming.